and we're going to continue with your coursework today. We're going to start with the skeletal system, and this should be beginning your next unit in this course. And hopefully you have been catching up with Unit 1 as you've got all your vocabulary memorized by now, you know, terms like frontal and mental and posterior, proximal, distal, because I'm going to start using those terms more and more as we go through Unit 2 and start talking about the bones. Now, one thing I'd like to say about the bones is I've broken down your information in your coursework into Section 6, which is bone physiology, and Section 7, which is bone anatomy. I don't want you to do those sequentially. Don't do Section 6 all at one time and then start Section 7. You kind of need to do those at the same time. It takes 3 weeks in a traditional class to learn all the bones. It's over 200 bones. And so all those bones are in Section 7. So you want to go ahead and start working on Section 7 as you progress through Section 6 and 8, which is the joints. So again, don't just work on Section 6 for a whole week and think you can cram Section 7 in a week. It doesn't work that way. It's too much information. So anyway, so let's just get started on the skeletal system. Let me introduce it to you. It's going to be a short video just to let you know how to progress through, or what to learn, what you need to learn over the next couple of weeks in the skeletal system. Hang on, let me get my pen. I really wish you could do this ahead of time, but you can't. Okay. So I put this schematic up here just to kind of introduce the whole skeletal system and what's involved in the skeletal system. Now, the skeletal system is not only the bones, but it's also the cartilages. So this picture has your bones and also some of your cartilages. And what I like about this picture is it's color-coded. And I'll talk about this again when I do the bone lab videos. But you'll notice that the skeleton, the bones of the skeleton, are broken down into two main skeletons, or two types of skeletons, an axial one and an appendicular one. Now, an axis is something that you can rotate around. So basically the middle of your body, including your skull, your vertebral column, and your thoracic cavity, your ribs, all this is considered your axial skeleton. Your appendages are the things that hang off, including your shoulders, your hips, and your arms, and your legs. And when you watch your lab videos, I have divided up the way you learn bones into your axial skeleton and your appendicular skeleton. So go ahead and start using those terms to describe where bones are. It's your skull, axial skeleton, your arms, appendicular skeleton. We'll also talk about cartilages in a later lab video, but you'll notice you have 3 types of cartilages. You learned that in the unit about tissues: hyaline cartilage, elastic cartilage, and fibrocartilage. And this picture has all those highlighted for you, so it's a great place to kind of go back and review. Again, we'll talk about this again when we start the lab videos. But this is the skeletal system, including the bones and the cartilages. Now, when we talk about bones, you can also call it osseous tissue, and hopefully remember it's a type of connective tissue. Bone and cartilage both are connective tissues. And this bone tissue is the main element of the skeletal system, and then you have the associated cartilages. These are around the ends of bones or between joints, things like that. And bone has cells, which are living, and an extracellular matrix. And the different thing about bone versus any other type of tissue is this matrix becomes calcified, which means it becomes hard. So it's the only connective tissue that we have that becomes hard. And it becomes hard because it has some calcium salts that harden and gives you in your teeth and in your bones and things like that. It looks like rock. Okay, so why do we even have bones? Number 1, support. It's our scaffolding. If we didn't have bones, then our body, we would just be big amoebas and we would just be big blobs on the ground. So you have to have this scaffolding of bones, your skeleton, to support. It also protects you. Think about where your brain is. Your brain's inside the cranial cavity. It's kind of like it's got its own helmet. Your spinal cord is protected by the vertebral column. And your vital organs, like your heart and your lungs, are surrounded by the rib cage. So very much a protective system. We also need it for movement. The muscles actually do the moving, but the muscles won't move unless they're connected to bone. So bone and muscle work together in order for you to move. It's a storage facility, and I like to use the word bank, for minerals such as calcium and phosphorus. And the main one that we're going to talk about is calcium. We use calcium not only for bones. You've heard drink your milk, you'll have strong bones because it's got a lot of calcium in it. We also have calcium that is required for muscle movement and also for nervous conduction. And so we need a certain amount of calcium in our blood. So if we have too much calcium in our blood, it will be taken up by the bone and stored. If we don't have enough calcium in our blood, then we will leach or release calcium from the bone into the blood so that our nervous system and muscular system can use it. So calcium is always moving back and forth between the blood and the bone. And of course, as you're growing, building bone, you need more calcium. So you would obviously need to have a high calcium diet as a child and going through puberty so that you can build strong bone. Another function of blood is hematopoiesis, which is a fancy word for making blood cells. This occurs in the bone marrow, and that includes making red blood cells, which you use to carry oxygen through your blood, and white blood cells, which your body uses as part of your immune system. You also have triglycerides, which are a type of fat storage. So you have some bone marrow that also is called yellow marrow. That's where you store a little extra fat. And again, it's real important in regulating that blood calcium. This kind of goes back up to storage. There is some endocrine regulation or hormonal regulation of blood calcium between the blood and the bones. And I'm going to talk about that in just a minute. Okay, so what kind of cells? When we talk about the bone, you're going to learn the big bones, the big picture, but you've got to learn the little microscopic anatomy of the bone as well. There's really just 4 bones that you've got to know, and honestly, really 2 are the ones we're going to make our main focus. You have the osteogenic cells, which are your kind of your progenitor cells. They're the cells that will give rise and become osteoblasts later. You have your osteoblasts, you have your osteocytes, which are your mature bone cells, and then your osteoclasts. And again, the ones that we're going to be mainly focusing on are the osteoblasts and osteoclasts. And osteoblasts are your bone builders, and so I say B for build, B for blast. So these are your bone builders, and your osteoclasts, these break them down. So osteoblasts are your builders, and your osteoclasts are the cells that break down bone. And again, we'll talk about that as we move through this unit. Now, we talked about that hormonal regulation, so let me just kind of talk about this negative feedback loop. Hopefully you remember that from the very first unit, talk about homeostasis and negative feedback. And you have 2 hormones that are involved in blood calcium regulation. You have one called parathyroid hormone, which we abbreviate as PTH. There's also one called calcitonin. And it really doesn't it's not that important in humans. Other animals, it's actually more important in other animals. But it's in your book, and a lot of times you'll hear about calcitonin and parathyroid hormone working together. Parathyroid hormone is made, fortunately, by the parathyroid, so it's easy to remember its name. Calcitonin is made by the thyroid. And you'll cover this again in 202, so it'll come back. So basically what happens, here's your balance beam. So think about homeostasis. You want your blood calcium level to basically stay in this range all the time. Well, if it starts to fall, say your blood calcium levels start to fall, okay, and so you need to have more calcium in your blood for this nervous conduction and your muscle contraction, your body sends a signal to the parathyroid hormone, to the parathyroid, to release parathyroid hormone. What parathyroid hormone does is causes osteoclasts to break down the bone. And by breaking the bone, kind of dissolving the bone, or it causes calcium to be released from the bone into the blood. Calcium levels will go back up, and you'll be in homeostasis. Now, calcitonin, on the other hand, if your calcium levels, if your blood, and I use this blood calcium concentration, if it's going up, so let's just imagine that you've just eaten a big bowl of ice cream with a milkshake and a glass of milk and some cheese, and you've just got this huge calcium load in your diet. You've got a lot of calcium being absorbed from your small intestine into your bloodstream. Have a high amount of calcium, well, your body kind of wants to take advantage of that, get some of that calcium back into your bones. And so what happens is your thyroid will release calcitonin. And calcitonin will cause the osteoblasts to build that bone, or take that calcium from the blood and put it back into the bone and bring your calcium levels back down. Again, the more important hormonal regulator of blood calcium levels is actually just parathyroid hormone. Calcitonin plays a small role in humans. It plays a bigger role in other animals, but again, a lot of times you'll see parathyroid hormone and calcitonin talked about together. Again, this is just another example of a negative feedback loop, which is basically how our body maintains homeostasis for so many different things. And you'll learn more and more of these negative feedback loops as you move through the course. Alright, so that is all I'm going to talk about to get you started with the skeletal system. Again, you'll see me on the lab videos. Good luck. See you later. Thank you.